Welcome to This Explainer. Today, we're cutting through all that viral UFO hype you've probably been seeing lately, and we're diving straight into the actual data-driven reality of humanity's search for extraterrestrial life. We've got a ton of ground to cover, from crazy distant exoplanets to the absolute farthest man-made objects out there in space, so let's jump right in. It all really starts with this one massive question. Are we truly alone in the universe? I mean, it's a question that's captivated us for generations, right? It's the whole reason our brightest scientific minds look up at the stars, build these unbelievably massive telescopes, and launch probes into the infinite dark. But actually finding that answer? Well, it's a whole lot more complicated than just peering through a lens. Just to give you a sense of the sheer, massive scale of this search, let's talk about the Breakthrough Listen project. Backed by brilliant folks like Stephen Hawking, this project spent 9 whole years analyzing 97 different galaxies. And in that time, they processed an absolutely mind-boggling 6 million radio signals. I mean, just try to wrap your head around the kind of computing power and absolute dedication it takes to comb through that much cosmic noise. So how do we actually do this? Well, our modern search basically boils down to 2 main methods. First up, we're listening for techno-signatures. Think of these as artificial radio waves, kind of like the ones our own TVs, radios, or satellites pump out. Finding one of these would be a dead giveaway for an advanced civilization. The second method? We look for biosignatures. These are very specific molecules hiding in the atmospheres of distant planets. Molecules that, at least here on Earth, are exclusively produced by living things. Section 1. Listening for techno-signatures. Let's dive into that first method. Trying to find a literal needle in a cosmic haystack requires some incredibly strict filtering. Scientists had to look for signals that actually had a Doppler shift, basically proving the radio waves were stretching and compressing, like an ambulance siren passing by, which means they were coming from a moving, orbiting planet. Then they isolated these signals into strict 5-minute on and off intervals. By applying this super rigorous methodology, they actually managed to narrow down those 6 million initial signals to just 1,519 really promising candidates. But, okay, here's where we get this brilliant kind of funny narrative twist. Out of those 1,519 highly promising artificial-looking signals, 0 actually came from aliens. Literally, 0. It turns out all 1,519 of them were just earthly background noise. The scientists had remembered to filter out our satellites, but, and get this, they initially forgot to account for the massive amount of interference coming from our own cell phones, microwaves, and TVs right down here on Earth. Whoops. Section 2. The mystery of K2-18B. All right, since actively listening for alien tech didn't quite pan out the way we hoped, the scientific community pivoted. Now all eyes are on a very special exoplanet about 124 light-years away called K2-18B. What makes it so incredibly fascinating is that it perfectly fits a model proposed by Indian-origin scientist Nikku Madhusudhan. It's believed to be what's called a Hycean World. Unlike our rocky little Earth, a Hycean world has this extremely thick blanket of hydrogen gas. That gas traps heat, which could potentially keep a massive, hundreds of kilometers deep global ocean warm enough to support liquid water. And where there's liquid water, there could be life. To figure out what's actually going on down there, we pointed humanity's most advanced eye in the sky right at it, the James Webb Space Telescope. By analyzing the starlight filtering through K2-18B's atmosphere, James Webb picked up carbon dioxide and methane. But crucially, and this is the big one, it also detected hints of a very specific molecule called dimethyl sulfide, or DMS for short. Now you might be wondering, why on earth is DMS making international headlines? Well, dimethyl sulfide is literally the smell of the sea. Seriously. Here on Earth, this exact molecule is exclusively produced by living marine organisms, mostly phytoplankton. There is basically no known, non-biological natural process that creates it in such massive amounts. So finding DMS on a giant water world 124 light-years away, that is an incredibly strong biosignature. It's an absolute game changer. But hold on, before we go declaring we've found alien whales or space plankton, the scientific mindset demands rigorous, bulletproof evidence. Right now, the data sits at about a 3 sigma level of certainty. To actually make history, scientists need to hit a 5 sigma level, which is 99.9994% certainty. Plus, they still need to find ethane, which is a common byproduct of DMS that's currently missing from the data. And finally, they have to exhaustively rule out any wild possibility that this DMS was just whipped up by some bizarre, non-biological chemical reaction we've just never seen before. Section 3. Messages in a Bottle. While we're meticulously listening and looking, humanity isn't just passively waiting around. We are actively speaking out into the universe. Way back in 1977, NASA launched the Voyager 1 and Voyager 2 spacecraft. Using this absolutely brilliant technique called a gravity assist, they used the gravitational pull of massive planets at Jupiter and Saturn to slingshot themselves faster and farther out into the dark. Fast forward to 2012, and Voyager 1 officially crossed the heliopause, that protective magnetic bubble around our solar system, making it the very first man-made object to enter the vast, uncharted emptiness of interstellar space. And attached to the side of both Voyagers is the Golden Record. It's basically our cosmic legacy in a bottle. It's a 12-inch, gold-plated copper phonograph disc designed as a comprehensive snapshot of humanity specifically intended for alien ears. The whole shebang is divided into 4 parts. You've got scenes from Earth, spoken greetings in 55 different languages, the ambient sounds of our planet, and 28 musical tracks. I'm talking everything from Beethoven all the way to the Indian classical Rag Bear V. What's truly deeply moving about the Golden Record, though, is what we consciously chose not to include. You won't find any mention of human war, destruction, or conflict on it. Instead, it presents this beautifully hopeful, peaceful, and highly idealized version of who we are. It's basically an optimistic handshake offered out into the cosmic dark. But wait, think about this for a second. How exactly do you send 115 photos into deep space back in 1977? We didn't exactly have JPEGs or digital hard drives back then. Well, NASA brilliantly encoded those 115 images into audio waveforms, pressing them directly into the physical grooves of the record. The cover itself gives these complex visual instructions on how an alien species could convert those audio signals back into a video feed. And the very first image they decode, it's just a simple calibration circle. That way they can prove they've set their screen ratio correctly before looking at the rest of our world. Genius, right? Section 4. The Scientific Mindset. We have definitely covered a lot of ground today, but we're concluding this seeker's journey not with disappointment over empty skies, but with a profound appreciation for the scientific process itself. Think about it. The false alarms of the Breakthrough Listen project, or the intense skepticism required for K2-18B, those aren't failures. They represent the ultimate winning scientific mindset. Science isn't just about those triumphant eureka moments. It's about analyzing our errors, reevaluating our tools, going back to first principles, and constantly improving the search. Literally, every time we stumble on earthly interference, we learn how to look that much deeper. Take a second to really think about this. 97 galaxies, billions upon billions of stars, and yet no definite sign of life like ours. The sheer vastness of this 14-billion-year-old, seemingly silent universe should remind us of something incredible. It shows us just how rare, how fragile, and how absolutely valuable our brief 80-year window of conscious life truly is. We are literally the universe experiencing itself. As we continue to hurl telescopes into orbit and cast golden records into the dark void looking for an echo, the greatest discovery might just be realizing the miraculous value of our own existence right here on Earth. So the question I want to leave you with today is this. In this infinite cosmos, how will you use your precious, fleeting moment of curiosity? Thanks for joining me for this explainer. Keep looking up and keep asking questions.